Integration by parts using the tabular method. With integration by part, the integral or the antiderivative of u dv equals uv minus the integral of v du. This is the rule for integration by parts. If the integrand can be expressed entirely at u dv, then the answer for the antiderivative will be u. U is one of the factors in the integrand. V is the antiderivative of dv minus the integral of v. Again, v is the antiderivative of dv, and du is the derivative of u. Notice that in the answer, we still have the integral signed. What that means is that we still need to evaluate the integral of v du to get the answer. Don't forget the minus sign here. One alternative is to set up the DIS method with two columns, the differentiation column on the left and the integration column on the right. In the first column for the differentiation, we will put u, and in the second column, the integration column, we would put dv. And again, u dv, u times dv needs to be the entire integrand that we started out with. For this method, on the left hand side, we take the derivative of u to get du, and in the second column, the antiderivative of dv is v. And we alternate the sign, starting with the plus sign and then the minus sign. To get the answer, we will cross multiply diagonally uv and then minus the integral of v du. And so in the integration by parts formula, there are two terms after the equal sign. The first term uv is the product diagonally u times v, and the second term, the integral with the integral sign, it is the product of v du. If this integral in the second term can be evaluated using integration by parts, then we can use the same method. This time, let's reset this and call du uppercase u and v uppercase dv. Then the derivative of uppercase u is d uppercase u, and the antiderivative of d uppercase v is uppercase v. Then the answer will be the product of u, v, both uppercase diagonally, minus the integral of v du. And again, we have to alternate the sign, plus, minus, plus. And so with integration by part, the integral of u dv equals uv minus the integral of v du. But alternatively, it can also be written at uv minus uppercase u times uppercase v plus, remember we alternate the sign here, the integral of uppercase v d uppercase u. One more time. The answer will be uv, multiply the two diagonally, multiply the two diagonally, and with the last row, we simply multiply them and put them inside the integral sign. With this method, in the first column, we keep differentiating. And so this is u prime, u double prime. And on the second column, we keep integrating dv is antiderivative, and then is antiderivative. The answer will be the product diagonally. We can stop at any row by multiply the two factors in the same row and put it in the integral sign. Don't forget to alternate the sign. And so for example, For the first formula, the product uv, and if we decide to stop at the second row, we take v times du and then put it in the integral sign. If we decide to stop in the third row, then we keep multiplied diagonally uv and then uppercase u, uppercase v. For the last row, take uppercase v times d uppercase u and put it in the integral sign. For example, when evaluating the antiderivative of x squared e to the x dx, using the integration by part methods with the tabular shortcuts, we put the algebraic factor on the left column, x squared, and the remaining e to the x dx on the right. In the left column, we keep differentiating. The root of x squared is 2x, the root of 2x is 2, and the root of 2 is 0. On the right column, we keep integrating. The antiderivative of e to the x is e to the x, the antiderivative of e to the x is e to the x, and the antiderivative of e to the x is e to the x. Don't forget to alternate the sign, plus, minus, and we multiply these diagonally. There are many ways to get the final answer here. If we decide to stop in the second row, then the answer will be x squared e to the x minus the integral of 2x e to the x dx. And again, we multiply the two diagonally, and we multiply the two factors in the second row and put them in the integral sign. Don't forget again the sign here, plus minus. Or if we decide to stop in the third row, then the answer will be x squared times e to the x minus 2x times e to the x, and we take 2 times e to the x in the third row and put them in the integral sign with the plus sign. And so the answer is x squared e to the x minus 2x e to the x plus, and then 2 times e to the x and put the product in the integral sign. Similarly, if we decide to stop in the last row, then the answer will be x squared times e to the x minus 2x times e to the x plus 2 times e to the x minus 0 times e to the x and put that product in the integral sign. And so the answer will be x squared e to the x minus 2x e to the x plus 2 times e to the x minus, take 0 times e to the x, put it in the integral sign. But 0 times e to the x is 0, and the integral of 0 is a constant. And so the answer is x squared e to the x minus 2x e to the x plus 2 e to the x plus c. In this case, on the left column, the eventual derivative is 0, so we should use this method and stop in the last row. In many cases, however, the derivative will not be eventually 0, and we might have to stop in the second row, the third row, the fourth row, and so on.